Three circles have radii 1, 5, and x. If the mean area of the three circles is 30 pi, the value of x is. So the first circle will have an area of pi r squared, which is 1 for the radius. Second one pi 5 squared, and the second one pi x squared. And then you're taking the mean, so divide those by 3, and they're saying that would equal 30 pi. So that's the math of this question. So here we go. So this is going to be pi plus 25 pi plus pi x squared, and then we'll just cross multiply here and give 90 pi. So let's just cancel out all the pi's, and then they're just going to get 26 plus x squared is 90, and therefore x squared is 64, and then take the root, and that's going to give you 8 for x, and therefore number 21 is D. Each of three doors is painted one color, either black, white, or gold. Each color is equally likely to be chosen for each door. What is the probability that at least one color is not used? At least one color is not used. So you can have all three colors used. That's the first scenario. So you can have one door black, one door white, one door gold, like that. Or you can have two colors used, which basically means that one color is not used. Or you can have just one color used, which basically means that two colors were not used. Two colors not used. Okay, so what do they want? They want, what is the probability that at least one color is not used? So they want these two guys. What's the probability of those two scenarios happening? Either this one or this one. Okay, well, the probability of, let's just call the probability here P, and therefore the probability of this would be 1 minus P, right? Because the whole thing has to equal 1. Yeah. And then I think I'm going to figure out this one first, because I think it'll be a little easier. So for example, if we have three doors, right? We have door number 1, door number 2, and door number 3. And we want this scenario, all three colors used. Okay, well, there's a few ways of doing that. Well, first of all, what is the total? The absolute total number of combinations. Well, for the first door, you have three possibilities, either, black, white, or gold. Three possibilities for the second door, and three possibilities for the third door. So we have 3 times 3 times 3, which is 27. So 27 is the total number of possible ways of coloring these doors. Now we want to figure out how many are in this category here. All three colors used. All three colors used would basically be a scenario like black, white, gold, right? So you initially might think, well, it's just one way. But there's iterations. There's black, gold, W. See what I mean? There's white, black, gold, white, gold, black. And I believe, what would be the other one? G, gold being first, and then black, white, white, black. Yeah, there you go. So that's 6, actually. So there's actually 6 in this category. So the probability, this guy, is 6 over 27. Yeah, 1 minus P. And I'm pretty sure that's right. So that actually becomes 2 over 9. So if 1 minus P is equal to 2 over 9, that means P would be 7 over 9. Correct? Yeah. And therefore that's the answer, because that's what we're trying to figure out. So 7 over 9 is the answer, and number 22 therefore would be A. Suppose A, B, and C are the last 3 digits of the 6-digit integer n is equal to 111 ABC. If n is divisible by 18, how many possibilities are there for n? All right. Interesting. Okay, well, see, you got 1, 1, 1, and then A, B, and C. So that means this number, let me just trying to figure out a range here. The smallest it could be was 1, 1, 1, 0, 0, 0, right? And the largest it could be was 1, 1, 1, 9, 9, 9. Okay, so less than or equal to. Yeah, that's the range. So we want to know how many of these numbers are divisible by 18. It shouldn't be that hard, actually. Just use your calculator, and calculators are allowed. I was initially thinking, when I first read it, that you're going to have to look at the divisibility, you know, like if it's divisible by 18, that means it's divisible by 9, it's divisible by 2, it's divisible by 3. But I don't even think you have to deal with all that. Let's just divide by 18. So just take the lower end, divide by 18. And what do we get here? We get about 6166.6, right? Because 6166 times 18 is 110988, I believe. So therefore that falls outside of the range. That's like way over here somewhere. But if we do 6167 times 18, then we're going to get into the range, and we do 111006. So that's the first number in this range that qualifies, that is divisible by 18. So then we just have to figure out what's the last number that qualifies. Well, the last number, that should be fairly easy. We have this number that we just calculated, which is 111006, correct? Plus a whole bunch of multiples of 18, because remember, it's just going to be plus 18 like that. And that has to be less than or equal to 111999, which is the upper end. And I think that should be good enough to do this question. All right, so let's figure this out. So that means 18x is less than or equal to 993, and therefore x is less than or equal to, divide that by 18, you get 55.1 or something. So therefore x is equal to 55. Now be careful though, because that means there's 55 additional numbers that are divisible by 18 in this range here. But remember we had the initial one, so you got to count that also. So the answer would be 55 plus that 1 that we initially counted, or calculated, I should say. And therefore the total will be 56. And 56 is answer choice C. In the diagram, each row, each column, and each shape shown by the thick lines must contain letters A, B, C, D, and E. If each square contains exactly one letter, what letter must be placed in the shaded square? Okay, so this is at the heart. So let me blow this up here, this shape, and I'm going to give them slightly different colors just to make it a little bit easier on myself. I'm going to make that red, that shape. Let's make one of these blue here. Let's make this guy blue. And let's make, what's the next one here? This one here, let's make that green. And the one at the bottom, let's just make that yellow. And then the shape in the middle, we'll just leave that black, the one that has the D in it. Yeah, that's the final shape. Okay, so let's take this one step at a time here. Hopefully I can explain this. I think this is sort of a puzzle. Like, you got to make this work. So let's see what happens here. Okay, so I'm just trying to think where to start. Okay. Okay, let's just start with the red shape that I colored red. Now, I'm going to concentrate on this guy right here. This guy. That one cannot be a C because the C is already in the red shape, right? Each letter can only appear in each shape once. So it can't be a C. Okay. It can't be an A or D because those are already in that row. Here's the A and here's the D. So it can't be an A, it can't be a D because those are in the row, and it can't be a C because it's in the shape. So that leaves B or E, correct? Yeah. B or E. Now, I don't know which one, but let me just put that in there. It's either a B or an E. And then this guy here, this guy has to be either a C or a B or an E. But it can't be C because it's in the same column as this C right here. So that one has to be a B or an E also. Yeah. So that means by process of elimination, this has to be the C. So that's good. I got one so far. Okay, let's keep going. Let's focus now on the bottom row. The bottom row already has an E in it. So none of these guys that are in the bottom row in the yellow shape can be E. But the E has to be in the yellow shape somewhere. So it has to be here. By that logic, therefore this is a B. And this is the E. You got it? So I hope that makes sense. I'm going to try to talk you through it. I don't want to, obviously I cannot just put in the letters because then that would not make any sense. And let me just make sure I did that right. I think I did. Okay, let's keep on going here. Now I'm going to focus on this A right here. This A. That A is already in that blue shape. So therefore, the four other boxes that are in that blue shape cannot be an A, right? So therefore, in that row, the A has to be here because A has to appear at least once per row. Okay, that's pretty good. And therefore, if we now look at that column, the first letter cannot be an A because we already have an A in that row. So the A has to go there. So you see what I'm doing here? I'm trying to work within the rules of the question. Okay, let's keep going. Okay, let's see here. What's next? Okay, now we concentrate on this red shape. Remember, all the 5 letters have to appear. So in that red shape, we have an A here, we have an E here, and we have the C. So the other remaining letters would be B and D, correct? Yeah, B and D. Now, the B and the D, let's see, where can they go? Well, the B is already in the bottom row, so I'm going to concentrate on the D. Either the D goes... let's think about this. Where can the D go? Well, we got 2 choices. It could either go here or here. And then same kind of story for the B. It could go either here or here. I'm not sure right now. But one thing is for sure, that if the B is already here, it can't go here in that corner. So that because the B is already there. And therefore, we also cannot put a D there because the D is going to be either here or here. So the D for the yellow shape has to go here by default. Yeah. Okay, and then now we can continue with something else. Let's turn our attention to the green shape, and in particular this box. That box cannot, well, we got A, B, C, D we got to fill, right? That box already has a C and an E. So this box right here that I guess I put that line, it's got to be either an A, B, or D. Now it cannot be an A because we already have an A up here, and it cannot be a D because we have the D. So by default, that has to be a B. So you're kind of moving right along here. And therefore, this must be a D right here. It can't be a B because it would be in the same row. And therefore, finally, we get this here, that this is the B. So as you can see, you don't really necessarily have to get the whole table. as long as you get that gray box, which is B, and therefore, if we go back to the original question, that would actually be answer choice B. In an arithmetic grid, adjacent numbers increase by a fixed integer a greater than 0, moving left to right within each row. Also, adjacent numbers increase by a fixed integer b greater than 0, moving top to bottom within each column. For example, the grid shown is a 3 by 3 arithmetic grid with a equal to 2, b equal to 5. Now suppose that an 8 by 8 arithmetic grid has a 1 in the top left corner and a number less than 75 in the bottom right corner. How many such grids have a 45 somewhere in column 5? So let us make a 8 by 8 grid, and let's see what happens. So 8 by 8, right? So here we go. I probably should have made this a little bit bigger. Yeah, that's okay, because we don't need to fill in the whole table. Let me just make sure I did the 8 by 8. Oh, forgot one more. Okay, that's 8 by 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay. Now, let's fill in what they gave us in the question. They didn't give us much. They just told us that's 1 and this is n. Well, they didn't say n, but they just said it's a number less than 75. That's all they told me. So I'm calling it n. And then they say that, it increases by a when you're going left to right. So this would be 1 plus a, 1 plus 2a, and so on. 1 plus 3a, 1 plus 4a, 1 plus 5a, 1 plus 6a, and 1 plus 7a. And then similarly, when you go top to bottom, it increases by b. So this is 1 plus b, 1 plus 2b, and so on, all the way up till 1 plus 7b. And then you don't have to fill in the whole grid, because I really just want to concentrate on this one, which is the column 5. That's what they're saying, that 45 is in somewhere in column 5. Okay, I believe that's column 5. So this would be 1 plus 4a plus b, correct? Let me just double check. I believe that is how you write it. Yeah. And then 1 plus 4a plus 2b. 1 plus 4a plus 3b. Probably should have made this a little bit bigger, but it's okay. 1 plus 4a plus 4b. 1 plus 4a plus 5b. 1 plus 4a plus 6b. And finally, 1 plus 4a plus 7b. Okay, I think that's proper. And then I want to concentrate on this n. This would be, let me think about this. 1 plus a plus 7b. 1 plus 2a plus 7b. 1 plus 3a plus 7b. 1 plus 4a plus 7b. 5a, 6a, 7a. So this is going to be 1 plus 7a plus 7b. Yeah, I think that's the n, this guy. Okay, so 1 plus 7a plus 7b is n, and that's less than 75. Okay, maybe we can get some information from that, because there's very limited information that they give us. So that means 7a plus 7b is less than 74. And if we factor out the 7, it would be a plus b, less than 74. And then divide through by 7, a plus b is less than 74 over 7, which is like 10 point something. A plus b would be less than 10 point whatever it is, 10.1 or 10.2. 0.5, whatever. But a and b are integers, right? They've actually been specific about that. Yeah, they're integers. The a and b are integers, and they're positive integers. So that means that a plus b, the highest it could be is 10 in terms of its integer value. Okay, that's a pretty decent start, I think. But now I have to concentrate on this column here. Okay. All right. I've got to concentrate on this column here. Well, this fact, I'm seeing a similarity between that and this guy. Not identical, but let me explain. So if a plus b is less than or equal to 10, if I multiply everything by 4, it becomes 4a plus 4b is less than or equal to 40. Now the one number that I circled in red, it's very similar, right? It's 1 plus 4a plus 4b. So all I have to do is just add a 1 to this side and it'll be 41. Got it? Now, a and b are positive integers, so that means that that number that I circled in red could never be 45. It's always going to be less than or equal to 41. Yeah. Okay. And very similarly, these other guys that are above it, this one, this one, this one, and this one, are also going to be less than 45 because they are less, right? So for example, 1 plus 4a plus 3b will also be less than 41 and therefore could not be equal to 45 because when you subtract a b, you're going to get a smaller number because b is a positive integer. And very similarly, 1 plus 4a plus 2b is less than 41. 1 plus 4a plus b is less than 41. And 1 plus 4a is less than 41. So none of these can be 45. So what that means is that the only candidates to be 45 have got to be these guys. This one that I'm circling in green, those three. So we've got either 1 plus 4a plus 5b, 1 plus 4a plus 6b, or 1 plus 4a plus 7b. These are the only ones that could be equal to 45. But we have to figure out how many different cases, because that's what the question's asking, right? How many such grids? So essentially what that means is how many ordered pairs AB do we get for these three equations where A and B are both positive integers? Well, I don't know. So let's take it one step at a time and let's figure it out. Okay, so first we'll try the first one. 1 plus 4a plus 5b is 45. And let's see if we can get any solutions that are integers. Okay, so first 4a plus 5b would be 44. And a is a positive integer. And therefore we'll start with the smallest positive integer, which is 1. When we sub that into here, we get 4 times 1 plus 5b is 44. And therefore when you calculate for b, it'll be 8, I believe. So there we go. If we make a little table here, 1, 8. That is one possible option for making the number 45 appear in that fifth column, basically, is the heart of that question. Okay, so you just keep going like this. A equals 2. When a equals 2, you would get 4 times 2 plus 5b is 44. And b would not be an integer. And then you just keep going. So I'll let you guys do that. And when you do keep going, the only other integer solution where both a and b are positive integers is when a equals 6. When a equals 6, you get 4 times 6 plus 5b. That's 44. And then for 5b would be 20, and b would be 4. So 6 and 4. There we go. So that's basically the strategy. So we've done this one. Now let's move on to the next one, which is this one right here. 1 plus 4a plus 6b. 1 plus 4a plus 6b this time is equal to 45. Same thing, 4a plus 6b is 44. And again, you go through your 1, 2, 3. But in this one, you can jump a little bit because this goes to 2a plus 3b is 22. And since this is even, this has to be even, but the 3 is not, therefore the b must be even. So you only need to worry about even values of b. It just saves a little bit of time, that's all. And just sub in b equals 2 and solve for a. And when you do, you get a equals 8. For b equals 4, you get a equals 5. For b equals 6, you get a equals 2. And when b equals 8, a will be a negative number, so that's not a solution. So we get 8 and 2, 5 and 4, 2 and 6. All right, so that takes care of this guy. And now we move on to the final one, 1 plus 4a plus 7b. So we got 1 plus 4a plus 7b, and that is 45. 4a plus 7b will be now 44, right? And this is a multiple of 4, this is a multiple of 4, so this has to be a multiple of 4. 7 is not a multiple of 4, therefore b must be a multiple of 4. So therefore b must be either 4 or 8. And that's a great way of saving a little bit of time instead of having to go through every single one, 1, 2, 3, 4, and so on. When b is 4, a is equal to 4. And when b is 8, a becomes a negative number. So there's only one solution there, 4, 4. And there we go. We got all the solutions. We have 1, 2, 3, 4, 5, 6. 6 solutions. And therefore 6 such grids can be made. And therefore the answer is A.